All right, so we'll finish up module 4 today, and that'll lead us into doing review. Maybe at the end of class, tomorrow will be a complete review day where we'll go through that practice exam that's in the exam 1 materials. Bring all of your questions if you have a chance to look at that ahead of time. I want to use that time to work through the questions that you have specifically. So I'll hopefully get some participation, kind of asking me questions. So I'm making sure I'm working through the problems that you have the most difficulty with. I wanted to mention something before we get going here, which is that participation quiz from yesterday. So I had one of the answers. I forgot to change it after putting the possible answers in there for the fourth one. So it was initially set to not be the correct answer. So I've got it changed now, so you should be able to see it. We'll work through it today, so there should be no confusion there. I just wanted to mention some of you might have seen your grades initially were a little low, and then I increased them to give everybody credit for that fourth question, which was initially set to not have the correct answer. So we'll go through that now before we jump into new material, kind of taking the time to review what we did last class, okay? So, and that'll set us up for today as well. So hopefully an easier one would be if we were thinking about simply calculating a price elasticity of demand, okay? So when we're talking about a price elasticity of demand, right? And this is where, let me make sure I get the numbers correct. So we've got our elasticity of demand. If we didn't have to use the midpoint method and we were given the percentage change, it was the percent change in the quantity demanded. Remember, price elasticity of demand. So the very first word, that is like the initial thing that's changing. So the price elasticity, so how responsive to price changes is demand, right? So this is like the thing responding. And we'll look at some other elasticities today, so this will become a little bit, we'll have more general kind of terms here. So whatever is the initial thing changing, that goes in our denominator. The thing that's responding, that's in our numerator. So here, if we're told the price of the textbooks is going what? Changing by 24%. And as a result, people buy 15% less textbooks. Remember, we're taking the absolute value. The law of demand would tell us, even though I just said a change in the price, what must that change have been? Well, if people bought less, we know that it was a increase in the price. The law of demand would tell us that. Now, when we're calculating the elasticity of demand, we simply take the absolute value. So here, I don't even know what this off the top of my head works out to be, 15 over 24. Well, if we're just trying to determine elasticity, if the numerator is smaller than the denominator, we know that that elasticity is going to be less than 1. So we know that we're going to have inelastic demand, right? Our range is there where anything from 0 to 1 was inelastic, right? Anything from above 1, and I should say less than 1 here, 1 to really infinity, right? Anything in this range, we would say it's elastic. And if it was exactly equal to 1, that was that unit elastic point. Right? And we'll kind of use this idea today looking at the entire demand curve. Okay? So our second question was, let's assume that we have gym memberships selling for $20. They increase the price to $30, and they sell, the number of memberships they sell goes from 120 to 100. What would our elasticity of demand be? Okay. So we initially kind of had this starting price of 20, and the resulting quantity demanded was 120. The price then went to 30, and the quantity demanded fell to 100. So if we wanted to calculate our elasticity of demand, we said previously it was the percent change in our quantity demanded over our percentage change in price. How do we calculate percent changes? Well, that was taking the difference and dividing it by the average of those two numbers. So for quantity, we would say, okay, take that change in our quantity demanded and divide that by our average. How do we find an average of two numbers? Simply add them up and divide by 2. Okay? So that would be our numerator. How do we find a percentage change in price? Same thing. I'll look at my my change in price, which it was going from what? When I flip-flop these, sorry, technically, this should be 100 minus 120, right? That was the new quantity was 100. So that change in price, we were going from 20 to 30. So that change was 10. Divide that by our average price. Add these two up. Divide by 2. And that should give us our elasticity of demand. Okay. Now, it doesn't really matter if I flip-flop these because remember, what do we have to always do at the end? We're just looking at whether or not, the magnitude. We're looking at just the absolute value. Okay. So if I do this, well, I've got 20 over 110. And then what? 10 over 25. Right. So let me use Excel to be my calculator here real quick. So we have what? 20 over 110 is approximately like 0.18. And then 10 over 25 should be about 0.4, right? So we do this, we're getting approximately 0.45 if we round this to the second decimal, okay? So that should be our elasticity of demand. So in this case, what would we say gym memberships are? Well, similar to our last one. If this is less than 1, we would say here that it's inelastic. And I don't think the question asked for that, but just to kind of be complete in our answers. Okay. So 0.45. And if we were asked if it's elastic, inelastic, we would know it's inelastic. Okay. Which of the following was going to be true about our perfectly elastic demand curve? Okay. So this is where reminding ourselves of the extremes will kind of help in some of the stuff that we're going to do today. If I have completely or perfectly elastic demand, that means people are going to be very responsive to price changes. So even if I don't want to draw a perfectly elastic demand curve, what can help me kind of remember this? Okay, if I saw a small change in price, if people are really elastic, that means that an initial price, whatever my quantity was, at this lower price, they're going to buy a lot more. They're very responsive to that price decrease. So I would have a demand curve that is pretty flat. Right? Now, what is perfectly elastic? That would be if I saw no change in price, but people still changed how much they were buying, right? Perfectly elastic. So if I had a completely horizontal demand curve, here I was thinking, to try to help us remember, if it's very elastic, very responsive, it would be a really flat slope. A perfectly elastic would be completely flat. So what's the slope of a horizontal line? That slope would be 0, right? Because how do we calculate slope? It'd be the change in our y over change in our x. Well, what's the change in my price? It's not changing at all, but I'm still seeing some change in my quantity demanded. So my slope is 0. But when we calculate the elasticity of demand, remember that's the percentage change in the quantity demanded in my numerator over that percentage change in price. Once again, what's the change in my price? It's 0. So if it's changing by 0, the percent change would also be 0. People are still changing how much they buy. So something greater than 0, anything divided by 0 would actually be infinity, right? Or infinite. So when we're thinking about what is true, well, we said for perfectly elastic demand, it's going to be horizontal, not vertical. The price elasticity would not be 0, it'd be infinite. Price elasticity, they're very responsive if they're elastic. So the only one that's, which of the following is true about perfectly elastic demand? So that one wasn't true, that one wasn't true, that one's not true. The only one that should be true is that the price elasticity of demand has that slope of 0. Okay. So this is where slope and elasticities are not the same. Slope of 0, elasticity would actually be infinite. Okay. And then some of the things we talked about, what makes demand more or less elastic last class, we said anytime I can find more substitutes, that's going to make me more elastic or more responsive to price changes. So fewer substitutes wouldn't make any sense. Less time to make a decision, I can't find as many substitutes, so we can kind of cross those out. We said if it's a greater proportion of someone's income, well, then that's like if you're buying a car or a house, people are a lot more sensitive to price changes. That will make it more elastic. So the answer there should have been a greater proportion. I think initially it was set. The answer I gave you yesterday in class was less time. I kind of added these and forgot to switch the basically behind the scenes when I type these in. Whatever the first answer I type in is, it automatically counts as correct, and I didn't have to change it. I forgot to change this one. But then this one will also not be true, which is if the product has a relatively low price, right? And we'll kind of talk about why this one today would actually mean if it has a relatively low price, it's more likely that we're going to have inelastic demand. Okay. All right. Any questions on any of those before we move back into the slides and covering new material? So I said we kind of worked through this Excel example as well. I want to go through a little bit more before we get there. I think we're down on slide 21 is where we left off. Right. So we've already touched on this, but we said the idea that slope and elasticity are not the same thing. So when we're talking about whether or not a good is elastic or inelastic, we were actually kind of being a little irresponsible last class because the same good can be inelastic or elastic if we're at different points on the same demand curve. So when we have a demand curve, the elasticity calculations will actually be different for different points on the curve. So with a linear demand curve, the slope is the same, but our elasticity will be different at different points, right? The slope, it's linear, so it's always going to be the same value no matter what 2 points we're looking at. But the elasticity, if we're looking at 2 different combinations of points on that line, might be different. Okay. A general rule of thumb is that as we move down that demand curve, our elasticity is going down or we're becoming more inelastic. So I've got an example here, but I think I'm going to draw like an extreme example to I think really hopefully convince you of this before we just start using that principle. So let's say I've got my quantity demanded, I've got my price, I've got my demand curve here. Whatever good this is, let's assume that initially we're starting out like 100. And to convince consumers to buy that very first unit, I've got to drop the price to 99. Okay. Well, here, my elasticity of demand, that's percent change in quantity demanded over my percentage change in price. Not using the midpoint method here for a second, so being a little bit irresponsible, but notice like if I'm going from 100 to 99, that's like a what? A 1% decrease in my price. If I go from 0 to 1, I mean, I can't even technically calculate this, right? Starting out at 0, it's like an infinite change in my quantity demanded. So initially, if I don't use the midpoint method, and if we did, we would still find a very large percent change in quantity demanded, very small percent change in price because the price started high and quantity demanded started low. So we know initially small percent changes in price will lead to really large percent changes in the quantity demanded. Well, then this, when we take the absolute value, is definitely going to be greater than 1. So initially, our demand curve is going to be very elastic, right? Now, as we move down that curve, we could think about, okay, let's say I got down here and I'm going from, I don't know, 2 to 1. And this is going to go from 99 to 100. This wouldn't mathematically work out correct, but just using these values to kind of make the point. Once we get to lower prices, we'll notice now when I'm thinking about my elasticity of demand, what's that change in price? Well, the percentage change, even though it's going down by 1, that was like a 50% decrease if we don't use the midpoint method. So we're having like pretty large, that same $1 change in price is now a very large percentage change. And that same dollar decrease in price, it only led to people buying one more unit. So same change in the quantity demanded. But if I start out at 99, a change of one is going to be a really small, so approximately, not quite, but approximately like a 1% increase in the quantity demanded. We take the absolute value. Notice, oh yeah, when we're at low prices, any change, that same $1 change is going to be a really large percent change in price as opposed to a small percent change. And that same increase of one in the quantity demanded will now be a very small percentage change. So this would now be less than one. When we're down here on the lower portion of our demand curve, now we get calculations where demand is looking like it's inelastic. So the same demand curve, we're actually going to have different elasticity measures at different portions of that demand curve. Okay. And if you just, not using these numbers, kind of a more general graph would be something like this, where if I'm looking at any demand curve, as I move down that demand curve, right, or as prices are getting lower, demand is becoming more, well, if I'm going from like something above one to less than one, it's becoming more inelastic, right? So we know that, for example, if I calculated the elasticity here and it was something like 2.2, then the elasticity down here must be less than that, right? It's going down. It doesn't necessarily have to be inelastic, but it has to be some value less than that elasticity we calculated initially. Okay. Any questions on this before we keep moving here? Okay. So I have some different numbers here, but if we have a linear demand curve, which is all we're going to be using in this class, initially when we're thinking about moving from like 30 to 20, that same $10 change in price, and if I use the midpoint method here, that percentage change in price would be 40%. But going from 0 to 20, if I use the midpoint method, right, so that change would be 20, the average is 10, that would be a 200% increase. So initially, I'm going to have an elasticity of my demand curve of 5 here. Now, if I think about that same $10 decrease in price, notice the number of units is still going up by 20. So the change in my quantity demanded and the change in my price is the same. But when I use that midpoint method to calculate the percentage change, we're now going from 20 to 10. So that change would be 10 divided by the average of 15. I get a 67% change in price. And then quantity, the change is 20 divided by the average, which would be 30. I'm also having a 67% change in my quantity demanded. So this portion of my demand curve, when I calculate my elasticity, it's actually unit elastic. This follows the rule that we said. As prices go down, or I'm moving down that demand curve, what's happening to my elasticity calculations? Well, it's becoming more inelastic, right? Going from 5 to 1. And then if I look at that same $10 decrease in price, but I'm at this lower price of 10 to 0, now my elasticity measure is going to be even lower, and now my demand curve has become inelastic. Okay. Yeah, so these values, the one I drew out for you, I was just kind of not using the midpoint method just to kind of get this idea of that it is becoming more elastic. If you use it, you could reproduce all these percent changes if you want. Now, when we do this, I said when you're using these values, it won't look like 200%. So for example, if I want to calculate the percent change in quantity demanded, if I take that change in quantity of 20, I divide it by the average of 0 and 20, which is 10. 20 over 10 is 2. But remember, we said when we're using that midpoint method, it's really the percentage change in decimal form. So 2 would represent 200%. And then like down here, if I'm calculating my quantity demanded change, percent change, sorry, the change would be 20 divided by the average between 40 and 60, which is 50. So 20 over 50 is 0.4. Once again, it's the decimal form of the percentage, so that would be a 40%. So yes, these values are coming from the midpoint method. I'm just not going to, we're not going to go through every single one. Yep. Good question. Okay. All right. Any questions there before we keep moving? So I'll kind of go through this, and I touched on this last class, but I'll go a little more in detail today. So there's going to be a relationship between elasticity and revenue. So even if we're not looking at different goods, I think last class I set this up saying producers generally want to have a good that's more inelastic. Well, the same good has different elasticities depending on where we're at on the demand curve. So where we're at in the curve, if I change the price, it might change my revenues by a different amount. So generally, we'll think about total revenues are going to be impacted by this elasticity. Why? Because total revenue is simply the price times the quantity sold, right? Well, if the quantity sold is responding to whatever that, or, the quantity demanded, which then ends up being the quantity sold, is responding to price changes, that percent change in the quantity sold will respond differently to the same change in price. Okay? So I'll kind of show you a numerical example here, and then I'll kind of back off and show you some shorthand. So just to kind of prove this to you, if I had a linear demand curve, right? Now here, I haven't really done this a lot yet, and it doesn't really matter how we do this, but if I have well, I'll take this. So quantity is equal to 5 minus P, right? So if I have my quantity demanded is equal to something like this, this is still a demand equation, right? Because it's the relationship of price and quantity demanded. It's just typically we write it out as price as a function of quantity demanded. Well, if I do that, so I move price over here, I subtract quantity demanded, I get what? Price is equal to 5 minus quantity demanded here. So I could just rewrite it. It doesn't matter. As long as I just have prices and quantity demanded, I can always rearrange this equation to be price as a function of my quantity demanded. Okay. So here, if I have a price of 5, right? The reason why I wrote, if I can get this out of the way, there we go. The equation this way is because you can hopefully easily see when the price is 5, what would the quantity demanded be? Well, 5 minus 5 would be 0. When the price is 4, what would quantity demanded be? 5 minus 4 is 1, etc. Okay? So I've got these different prices and corresponding quantities. What would my total revenue be? Well, total revenue is simply price times quantity. Right? So 5 times 0 is 0, 4 times 1 is 4, 3 times 2 is 6. This is kind of an easy example here. So what we'll notice is that as I'm decreasing the price, and each decrease is a price decrease of $1, people are buying one more unit. So it's the same changes in price and quantity. Right? The slope is the same, but our percent changes will be different. So if I use the midpoint method, and once again, those values I'm representing as percentages. So if you do the actual calculations, so here to find that percent change in price, you would do a change of $1 divided by the average, which is 4.5. You'll get the decimal form, so you have 0.22, right? But between each one of these prices and quantities, I can calculate those percent changes. I then calculate my elasticity of demand, which is the percent change in quantity demanded over percent change in price. And I'll notice initially, and I didn't drop the negative sign here, but really large elasticity measures, initially when prices are higher, my demand starts out as elastic. As we kind of move to lower and lower prices, or we move down that demand curve, we said, what's happening to our elasticity of demand? It's becoming more inelastic or getting closer to 0. Right? So we already talked about this, right? When we look at lower parts of the demand curve, my elasticity is getting closer to 0. I'm becoming more inelastic. Well, notice initially, when demand is elastic, if I decrease the price, what's happening to total revenues? They're going up. So whenever demand is elastic or above 1, by decreasing the price, I'm increasing my total revenues. Now, when demand is unit elastic, notice what happens if I change the price there. Total revenues actually stay exactly the same. And then when demand is inelastic, if I continue to lower the price, what's happening to my total revenues? They're going down. Okay? So this relationship between elasticity and total revenue is that if I lower the price when demand is elastic, that will increase total revenues. If I continue to lower the price when demand becomes inelastic, what is that going to do? It's going to have the opposite effect or decrease my total revenues. So why is this the case? Right? So go here. got a movie ticket example, but I want to draw this out for you a couple different ways to really hammer home this idea of why that relationship exists. Okay. So if I have my elasticity of demand, and I think I did this last class, but it'll help us to see it again. If total revenue is price times quantity, okay? If I have, and I'll set this up using colors here. Oh, okay. If demand is elastic, we know that elasticity is greater than 1. What does that imply? That implies that my numerator must be greater than my denominator. Okay. So if demand is elastic, if I lower the price by a little bit, I know the response from demand is going to be even larger. Right? So the same would apply with numbers. I'm just using the size of arrows to kind of notate which of those is larger, because then I think it's easy to see, okay, when demand is elastic, when I lower prices, I'm going to make less per unit, right? That's a bad thing. I'm making less revenue, right, per unit. However, that is more than compensated by the fact I'm selling way more units now. So what is the total effect of that price change when demand is elastic? Total revenues would be going up. Okay. Any questions on that idea? I think this sometimes is a little bit more intuitive to think about why that relationship is between elasticity is what it is, and total revenues and elasticity is what it is. Now, let's say I'm on the elastic portion of my demand curve. I'll write out this equation again, just so we can kind of think about what happens if I were to increase the price by a little bit. Well, I know the response from demand, if I increase prices, people are going to buy less. And if they're very responsive, they're going to buy a lot less. So if I'm on the elastic portion of my demand curve, if I increase the price, what am I doing to total revenues? Decreasing them. Okay. And then we can think about a very similar scenario, right? So if I have inelastic demand, so let's say here, I've got my total revenue is price times quantity. And I'm now thinking about, okay, demand is inelastic. That must mean that my elasticity measure is less than 1. So what would that imply? Well, the only way this fraction is less than 1 is if that percent change in my quantity demanded is less than the percent change in price. So now, if I lower prices by a lot, I know the response from demand is going to be less than that. Which of these kind of wins out? Well, the larger percent change. So I would actually see that when demand is inelastic, if I lower prices there, because people aren't as responsive, I would actually be making a lot less per unit and not selling that many more units. So total revenues would actually go down. So that same price decrease, right? There we go. We'll have different, oh, come on. We'll have different effects on total revenue depending on if demand is elastic or inelastic. And then if I've got inelastic demand, well, when it was elastic, we said price increases actually hurt total revenues. But if it's inelastic, if I increase the price by a lot, if people aren't as responsive, that decrease in the quantity demanded isn't going to be near as large. So there, increases in price, if demand is inelastic, would actually increase total revenues. And I like these errors. Like this is kind of like how I would learn, but you can also just use intuition. If people are really responsive to price changes, well, then when I lower the price by a little bit, I'm going to sell way more units. So there, my total revenues will go up. If they're inelastic, well, then if I change the price, they're not going to be very responsive. So I might sell about the same number of units. But if I'm increasing the price and I'm selling almost the same number of units, I'm going to increase my total revenue. So I want to do different things, right? I want to change the price in different directions depending on if demand is elastic or inelastic. Okay. And then I'll go through this one kind of quick, but what if it was unit elastic? Well, there, whatever my change in the price is, I'm going to have the exact same percent change in quantity demanded. So it's like they almost like wash each other out. So if I have unit elastic demand, changes in the price aren't going to change my total revenues at all. Okay. Any questions here before we keep moving? So with this idea in mind, if I'm looking at a demand curve, we'll kind of combine all of this, right? We said initially, demand is going to start out as relatively elastic. As we move down the demand curve, it's becoming more inelastic. Eventually, we'll get to prices where it does become, in fact, the elasticity is less than 1, or it is inelastic. So if we map these out and we think about, okay, for these different quantities sold, what would be the corresponding total revenue? So as I'm changing the price, I'm getting to different quantity demanded. At these different quantity demanded, or these different number of units, what's happening to total revenues? Well, initially, as I'm decreasing the price, right, what am I doing? Right? If it's elastic, we said total revenues being price times quantity. By lowering the price a little bit, and here I can actually do it in colors, but so if I'm lowering the price, I know that people are going to be very responsive. So what's happening to total revenues? They would be increasing. So initially, when I'm lowering the price, total revenues are going up. Okay. Over here, we said if demand is inelastic, if I want to keep selling more units and I'm lowering the price here, well, as I lower the price, what's happening to total revenue? Well, here, if they're inelastic, price decreases, people aren't responding. They're not buying that many more units. And so there I would just be decreasing total revenues. So for every quantity out here, when I'm lowering the price, what am I doing to total revenues? I'm actually decreasing them, right? So we can kind of map these quantities to different total revenue points. Okay, so initially, lowering the price when demand is elastic, which we know the top part of the demand curve will be elastic, we're increasing total revenues. Once we get to the inelastic portion of the demand curve, which is lower here on the demand curve at lower prices, if I continue to lower the price, sell more units, I'd actually be decreasing total revenues. And then what about the point in the middle where it's unit elastic? We said that's where it equally offsets. So you kind of think about like you have like this, and I'm drawing it larger than it probably is. In practice, this is probably like a really small, right? There's truly only like, a peak where it would be the same. But this is kind of the idea of like how we would think about mapping that relationship of our demand curve, which we know the elasticity is getting lower and lower, and what those price decreases would do to our total revenue. Okay. Any questions on that idea before we jump back into the slides here? Okay. Where are we at in time? Oh, we got plenty of time. Let me see. Oh, I'll save this example. We'll go through this stuff here in just a second. But we were looking at that table. I then kind of drew this graph out for you where you can see really the trade-off that exists, the reason why total revenues are impacted differently with price changes, if it's demand is elastic or inelastic, is because we can think about it when I'm lowering the price, right? I'm making less per unit, or if I increase the price, I'm making more per unit, but I'm selling fewer units if I increase the price, right? And if I lower the price, I'm making less per unit, but I'm selling way more units, okay? So I kind of already drew out this relationship for you. We talked about that unit elastic point being where total revenues are maximized. So if I'm thinking about like a demand curve. If I'm up here on the elastic portion, I want to lower the price until I get to this unit elastic portion because that's where total revenues are maximized. If I'm on the inelastic portion of the demand curve, well, what would I want to do? I wouldn't want to lower the price. I'd actually want to increase the price. So think about no matter where you're at on that demand curve, you want to move towards the unit elastic point, which will be somewhere in the middle of that demand curve. Okay. So we went through all this. We'll come back to the movie ticket example in a second. Once we've talked about everything, I'll kind of use it to be almost like a review of everything we've talked about. So another way of thinking about this relationship of total revenues and elasticity. So I'm using that same example where we've got kind of the same value. So it just started out at 5 and went down by, had a slope of -1. So think about here if instead I'm looking at like lattes, I guess is the good I chose. But initially, if I were to lower the price, right? So let's say I'm starting out at a price of $4. Right? How much money am I making? Well, at $4, I'm going to be able to sell one of these lattes. So what's my total revenue? Price times quantity, I'd be making $4. Right? If I then lower the price to 3, well, I'm making one less dollar on that first unit I'm selling, but I'm selling a second unit for $3. So the gain I have there is 3, the loss I have is 1. By lowering the price when I'm on that elastic portion of the demand curve, how much have I actually gained? Total revenues have went up by $2, right? Kind of my net gain there. Now, if I then lower the price from 3 to $2, well, compared to before, right, when I was charging 3, those first 2 units, I'm losing $1 on each. But I've convinced this consumer to buy a third drink, so I'm now making the new price of $2 on that third drink. These would equally offset each other. This would be what has happened to total revenue. It hasn't changed. This is our unit elastic point or unitary elastic point on the demand curve. Okay. And then if we want to keep going, if I lower the price from 2 to 1, well, now I'm making $1 less on each of those first 3 drinks I was selling. I've convinced the consumer to buy a fourth. So I'm making $1 now, that new price of $1 on the fourth unit, but I lost $1 on each of the first 3. My net gain there would be I'd lose $2 of total revenue. So when I'm on the inelastic portion, if I continue to lower the price, I actually see that total revenues would go down. Just another visual of kind of, or another way to visually see this, okay? This relationship between elasticity and total revenues, okay? All right, I already drew out that kind of relationship, the more continuous one of demand and total revenues for you. So now we're going to go to thinking about all of this with some actual data. Okay. So I have this Excel file that's up on Canvas. Let's see. Should be under the Module 4 tab. I just had it pulled open before class. So this elasticity example movie, that's the file I'm looking at here. So I had a bunch, every single year. It has the number of tickets sold, total box office. This is kind of like your revenues here, adjusted for inflation. But we also have ticket prices. Okay. So notice what I did here, and actually I could recreate this and just do kind of the most recent, but I think I chose 2018-19 because, there was some COVID stuff here. It kind of got wacky. So I tried to choose stuff before COVID. Okay. So from 2018 to 2019, what was the change in the quantity demanded? Well, tickets sold, that's kind of our quantity. So it fell, right? It decreased. So I took that change, simply 2019 minus 2018's quantity. I then divided that by the average, just adding those two values up and dividing by 2. Now, I don't have this as a percent. What could I said if you calculate it using the midpoint method, it'll be the decimal form. One way I could kind of do this just to make it easier, if I go to this cell, I can multiply it by 100 so that I can see what the actual percent changes were, right? So in here, I did the same thing for price between those 2 time periods. So the change in price divided by the average, I'll multiply it by 100 here so we can see what that percent change was. So notice here, the percent change in price was 0.13%, and the resulting quantity demanded, when that price went up, people bought what? 1.63% fewer movie tickets. So this is good. The data supports the law of demand that when prices go up, we see less units sold. How would I find my elasticity? Simply take that percent change in the quantity demanded divided by the percentage change in price, right? Now, I didn't have this in there, but we know that we want to drop that negative sign. There's a function in Excel, which is the absolute value, which will just drop that negative sign. Or you could have done, -1 times that just to get rid of that negative sign. So initially we have this elasticity of 11.92. Okay. So notice what should be happening when prices go up, right? If I've got elastic demand, so here, and we had this here. So if I was on the elastic portion, and I've got extra stuff here, so I'll just draw it out again just so we can kind of keep it clean. So if you're ever wanting to do this yourself, you just say, okay, look, I've got my demand curve. I know initially it starts out as elastic. Down here, it's going to become inelastic. I can map those quantities out, the total revenues, and I know that it should look something like that. So if I was on the elastic portion of my demand curve and I increased prices, well, what's going to happen if I increase prices? Quantity is going to go down. If I'm on the elastic portion, my total revenues from that price increase should also go down. Okay. So what has happened when we're on the elastic portion and prices went up? Total revenues or total box office, right? Or even after we adjust for inflation, what's happening? Total revenues are going down. Okay. So the data supports what we're talking about. So this is a good thing. Now, I'll also kind of use this to make a point. So if I look back at some older time periods, right? And what's true here, the prices were lower. Okay. Now there's a little bit of goofiness here because we do have inflation, but let's just assume we didn't for a second. If we're looking at lower prices, right? What should be true, right? So I'm gonna kind of make a point. If I'm looking at lower prices, it should be that my elasticities do what? Become more inelastic. So this is where when we're analyzing these things, we're holding everything constant. There's likely some things that we're changing in these time periods that we aren't able to hold constant. So if you're looking at actual data, you might calculate the elasticity here, same exact way. It actually looks like it's more elastic at lower prices. This looks like it goes against what we were saying, but that's because when we're talking about these relationships, we're holding all other factors constant. When we're looking at actual data, those factors aren't held constant. So we have to kind of do some of this stuff with a slight grain of salt here. But I don't know. I want to kind of use that to kind of make this this point of when we're trying to apply this to real data, we need to always keep in mind all these things we're talking about in class is holding everything else constant. We're trying to analyze the relationship between price and the quantity demanded, holding everything else constant. When we're looking at different time periods, it's likely those things aren't going to be held constant. Okay. Any questions on that before we keep moving? Okay. All right. So where are we at in time? Oh, we got plenty of time. Okay, good. Oh, so before I continue, are there any questions about kind of this relationship of elasticity, total revenues, or any clarification? Because we're going to switch gears here a little bit. Okay. All right, just making sure I could see the chat there. Oh, now I want this thing to go away. There we go. So we've talked about the price elasticity of demand. We can look at a bunch of other elasticities as well. So we'll focus on a couple that are related to demand, and then we'll talk about supply. So one of the elasticities we can also measure is the cross price elasticity. So this looks really similar to what we were doing, but notice here, I want to know how does that good X respond, right? How does the quantity demanded of good X respond to a change in the price of another good Y? Okay. So this is going to start to sound similar to when we were talking about substitutes and complements in consumption, right? So if I had this cross price, so cross price elasticity, of demand, right? So what's the initial thing changing? Well, remember, when we talked about the elasticity of demand, here we're looking at the elasticity between two goods. So it's going to be, what's the initial thing that's changing? It's the change or the percentage change in the price of another good, good Y. And then we want to know, how is the demand or the quantity demanded responding for good X? So still kind of follows our same principles as the price elasticity of demand in the sense of the first word is going to be in your denominator. It's the thing that's initially changing, the price of some other good, cross price. And then how does the demand for the good you're looking at, X, change as a result of that? Now, what we don't do here that we did with the price elasticity of demand, we always know the price elasticity of demand is negative. Well, what if I had substitute goods? Okay. We don't take the absolute value here because if I have substitute goods, what's my cross price elasticity of demand going to be? Well, if I have any change, and I'll put a number to it here, but let's say I've got a 10% increase in the price of good Y. If these are substitute goods, when the price of Y goes up, people are going to be less likely to want to buy good Y, and they're going to substitute towards good X. So a 10% increase in the price of Y is going to cause the quantity demanded for good X to also go up, right? If they're substitutes, these two things will have the same sign. Same kind of thing. What if the price of Y goes down, right? Well, if they're substitutes, when Y becomes cheaper, people buy more of good Y, less of good X. So I might see that when the price of Y goes down, people buy less of good X. Oh, these are both negative. What will the elasticity of, the cross price elasticity of demand always be for substitute goods? A positive value. Always be a positive value. Okay, with this idea in mind, what about the cross price elasticity for complements? Right? Well, if they're complementary goods, when the price of Y goes up, if I'm using these two goods together, we said when Y becomes more expensive, this is the idea of like, I used to use like a clicker. Well, I still do if I have people in class, just not with a web-based class. I use a clicker to go through my slides. I always kind of use the example of, what if the price of batteries went way up like $100 for AA batteries? What do you think happens to my demand for that clicker? Goes way down, right? Because I can't use it without the batteries. So if they're complementary goods, when the price of one, that Y good goes up, the good that I need to use with it, I'm actually going to buy less. Right? And then same kind of idea. What if the price of batteries goes down? Well, then I might be more likely to use the goods that require those batteries. So if I have complementary goods, what's the sign of my elasticity always going to be? Negative, right? I'm going to have different signs on those two changes, on those 2% changes. So the cross price elasticity, we don't drop the negative sign because the negative sign tells us something about whether or not these goods are substitutes or complements. Okay. So we've got substitute goods will always have a cross price elasticity of 0 or above 0 or positive. Complements will always have a negative cross price elasticity. Okay. Just to be complete here as well, we can think about, well, I'll leave this here and kind of use this. Not only can I determine from that cross price elasticity whether or not there's substitutes or complements, but I really have like different ranges. So what if I had a cross price elasticity, so let's say like negative infinity all the way to kind of 0. So I'm like thinking about like a number line here. Okay. Well, between negative infinity and -1, well, if I have an elasticity that an absolute value is greater than 1, here this would represent, well, when this would be a complement Pretty good. So complements. But if it's greater than 1 in absolute value, we would also say that this cross price elasticity is elastic. Right? In this range, if it's negative, well, tells me that they're complements, but we would say the cross price elasticity is inelastic. So anything that's elastic, that means that a small percent change in the price of good Y causes really large percent changes in good X. This must be that they are like strong complements. Whereas if it's negative, but between 0 and 1, it's inelastic. We would say they're complements, but they're weak complements. Right? And then we would kind of have on the other side, anything between 0 and 1. Well, it's positive, so this is telling me that they're substitutes, but it's inelastic. So we can kind of think about here, these are like weak substitutes, weak complements, strong complements, and then anything from 1 to infinity, well, it's positive, so that's telling us they're substitutes. However, that cross price elasticity is elastic, so we think about those as strong substitutes. Okay. So we can still determine if it's elastic or inelastic. It's just we now have twice as many ranges, right? For every positive range, we have a negative range as well, because the sign for the cross price elasticity tells us whether or not they're substitutes or complements. Okay. Any questions on that idea before we keep moving? Okay. So we can do a very similar thing, but for the income elasticity of demand, right? So, and I think, did I use I or M? I think we typically, I just want to make sure I'm keeping my notation consistent here. Yeah, I was gonna say I probably used M because that's kind of what we do in economics, right? So if it helps, in the slides, this is M, but you can think about this as like your income elasticity of demand. So once again, if I've got my income elasticity of demand, right? The initial thing changing is no longer the price of the good. I'm now thinking about percent changes in income and the corresponding percentage change in my quantity demanded. So what is this going to tell us? Well, if income goes up and people buy more of something, we said that was a normal good. So if income goes down and I buy less, notice both cases here, my income elasticity is going to be positive. So anytime my income elasticity is positive, I've got normal goods. What if instead I've got, this income elasticity of demand? If I have more money, but I buy less of something, that's telling me it must be an inferior good. Or if I have less money and I buy more of it, inferior, right? You can go in either direction. Well, notice in this case, what's the sign of my income elasticity? Opposite sign, so this would always be negative. So a negative income elasticity tells me that they're inferior goods. Positive income elasticity tells me that they're normal goods. And then same kind of idea, I won't draw it all out, but you would have your different ranges, right? If it was positive, but between 1 and infinity, that means it's elastic. So this would be like a normal good, a strong normal good, right? And then in between 0 and 1, it would be a weak normal good, so on and so forth, okay? So cross price elasticity and income elasticities of demand, the sign tells us about a characteristic of those goods, right? Whether or not they're substitutes or complements. And then for the income elasticity, whether or not they're a normal or an inferior good. Okay. Any questions on that idea? So with this idea of like strong substitutes or weak substitutes or strong normal goods or weak normal goods, would also, and this isn't going to play out on the exam. I'm not going to try to like make you categorize these, but just kind of out of interest, 0 and 1. So these would be positive, so normal goods, but kind of what we'd say like a inelastic normal good. that means that when the percent change in income, we're not really seeing demand respond a lot to that. So this would be something that we usually think of as like necessity goods, right? So food, doesn't matter if my income goes up or down, I still need about the same amount of food every day. And it doesn't matter if my income goes up or down, I still need about the same amount of gasoline to get to and from work. So these would be kind of inelastic. They're not very responsive to income changes, but they still are normal. When I have more money, I typically do still buy a little bit more food, or I do, I travel a few more places, so I will use more gasoline. Now, luxury goods are going to be where changes in income, we see huge percent change in the quantity demanded. So this is typically going to be things that like move from a quantity of 0 to 1 because that's always going to be a large percentage change in the quantity demanded. So, fancy cars, new houses, Rolex watches, all these luxury goods, we see elasticities positive and greater than 1. We would kind of call those luxury goods. So I put a link in here. I think it's somewhat interesting. So this is actually like a oh, peer-reviewed article, right? And they were looking at income elasticities of different foods. So let's see, I think there was, so you can kind of see, they even look like at a nutrition breakdown. So, and I think this was in China, if I remember correct. But what was kind of an interesting result of this was, yes, it looks like food is typically a necessity good. But if you break food down into different categories, different types of food become luxury goods. So for example, if I'm looking at something like apples, bananas, corn, all their measures of income elasticity were between 0 and 1. So they're normal goods, but people didn't buy that many more apples when they had more money. On the flip side, um, the building people, I still haven't gotten a response of how I keep these lights on other than moving like a crazy man, trying to wave my arms, which I forget to do. So, another interesting thing in this article was that they found that for some goods, for some food items, they actually had luxury goods. So this was things like that were kind of higher nutrient based, or like we're trying to sell themselves as like health goods. So like organic bananas actually look like they're luxury goods, right? When I don't have a lot of money, right, changes in my income, um, it's a normal good. I might buy more bananas, but not that many more. However, once I start to get more money, if it's a luxury good, right? Well, I might have not been buying organic bananas before. When I have more money, now I start to buy them. So we see that same percent change in income for these luxury goods, things like organic food, higher end, I don't know, caviar, things like that. Those food items actually tend to be luxury goods. So all right, that was kind of interesting, once again, to kind of break this down that if we have a general category like food, we might have a very different income elasticity measure than if we break that food down into multiple categories, right? Some foods might be luxury goods, some foods might be necessity goods. Okay. And then a terrible cheesy meme is your income elasticity greater than 1 because being with you is a luxury good. Right? That kind of lines up with what we were talking about. I won't really waste too much time here because I have an example I think is more worthwhile. But I also can find the price elasticity of supply. So once again, what's the initial thing changing? The price that goes in my denominator. What is responding? Supply. It looks the exact same as our price elasticity of demand. It's just that instead of the quantity demanded, we're looking at the quantity supplied. Okay. Same ranges apply here. I don't even have to take the absolute value because we know the relationship between price and quantity supplied. We have an upward sloping supply curve will always be positive. So it makes it almost a little bit easier when we're looking at the price elasticity of supply. We don't have to worry about that negative sign. So everything would apply the exact same way. So what are some things we talked about, some determinants of demand that impacted the price elasticity of demand? What are some things that would impact the price elasticity of supply? So how responsive are producers to changes in the price of a good? Okay. So flexibility that the producers have. So the more flexibility that they have, when the price of a good changes, they can be more elastic. Okay. So what, I didn't mean for this to all pop up at the same time, but what does like flexibility really look like? Well, that might mean I have, in my factory, an extra area that I'm not using, but that I could be using. right? So I might have extra capacity so that if the price does go up, I can use that to produce even more, right? I might have like temp workers, right? Where I can kind of, they're not there every single day, but I can call them in for a week if all of a sudden I want to produce more that week, right? So anything that gives me more flexibility in my production process, that's going to make me be able to respond to price changes more responsive to price changes, more elastic. Right? Also, not having a brick and mortar building. So the idea there being if I am pretty mobile and whatever I'm selling, I can move to whatever area has the highest price. I can be really responsive to price changes if I can relocate my business relatively easily. Now, brick and mortar, this is a little bit harder to do. And so if I have a brick and mortar, company, I'm selling something and my production, facility is set up, huge manufacturing plant, it's very difficult for Ford to move their production facility of automobiles to a different area. They're going to have to probably transport those have additional cost. But if I'm selling something like, I don't know, I have like a food truck, if I know that all of a sudden the price in certain neighborhoods, people are willing to pay more because they're more affluent, I can take my food truck to that area. I can be very responsive to those price changes. Okay. And then same kind of thing with price elasticity of demand, just like time impacted how many substitutes consumers could find. Time is also going to allow suppliers to really be more flexible. So if they have more time to make their production decisions, they're going to be able to be more elastic to price changes or more responsive. If they have less time, right, less elastic. So same sort of relationship exists for the price elasticity of supply as it did for the price elasticity of demand. It's nothing too crazy there. So had an example with the price elasticity of supply, which is tragic, but also I think interesting and gives us a way of thinking about supply and demand in different markets. So I get kind of tired and I use them because they're easy and they'll connect with you the most. But talking about like food, houses, all of those are like traditional markets. And yes, we want to be able to analyze those markets with the principles that we're talking about. But you can think about there's really things that are you might not think of as a market, but there actually is. So this paper had this example of Sudanese slavery in the 90s, right? And this is kind of goes to show we need to really think about what we're doing and think about how these economic principles could lead us to making better decisions. So in the 90s, all these humanitarian groups, and I think they were doing some of this like through fundraising, like even through like religious churches, things like that. They were getting this money and they were like, oh, help donate to this cause. We're going to go purchase slaves from Sudan and then set them free. Right? So it sounds like on its face, really like a good idea. Right? The only problem is if I'm going in as a humanitarian group, how am I able to purchase the slaves from other people? Well, I'm having to be willing to pay a higher price than what the people previously buying or purchasing these slaves were, right? So when they go in and pay a higher price, well, what's going to happen to the quantity supplied? If the price being paid for a slave is higher, what might some people in Sudan have decided to start doing? Going out and enslaving more people. The quantity supplied is likely going to increase, right? Now, this wouldn't be a huge problem if the elasticity of supply for slavery was inelastic. The problem is it was fairly elastic. So even though these groups were offering not that much higher of a price, but somewhat higher, so a small percentage change in the price there, if the price elasticity of supply was elastic, that meant the quantity supplied, percent change in the quantity supplied went way up, right? So by coming in offering to pay these higher prices because the price elasticity of supply was elastic for slavery in Sudan in the 90s, you saw the number of people being enslaved increase by a lot, right? So did the humanitarian efforts work? No, right? And this is once again, it's weird. We don't want to think about slavery as a market, but really it is, right? People, and unfortunately, right, the product is slaves, right? People being enslaved. But if you go in and are willing to pay a higher price, you're going to automatically increase the quantity supply. Okay. So I don't know, thought kind of an interesting example to kind of connect with some of the things that we were talking about in this chapter. I also have a link, kind of interesting. So this paper, once again, another peer-reviewed article, they were measuring and they had like a way of, I think, if I remember right, they actually found heroin users, yeah, and they were giving them like artificial budgets and asking them how much, if you had this much money, how much heroin, how many packs of cigarettes, et cetera, would you buy? And then they recorded all that data, ran some fancy regressions, and came up with the elasticities for that. So they had 120 heroin users, artificial budgets, and I think they give them, yeah, four goods. So cocaine, marijuana, beer, and heroin. They said, if you had this much money, here were the prices of these four goods. How much of each one would you buy? Right? So subject one, for example, said, if I gave you, if heroin was $6, and then all of a sudden, we change the price of heroin and we ask you again, now it's $10, how many would you buy? And you reduced your quantity that you would buy from four to two. Well, what can I calculate? I've got two prices. I've got two quantity demanded. I can actually calculate heroin users' price elasticity of demand for heroin. Now, spoiler alert, what do you think the elasticity for heroin use probably is? Well, change in the price, if I'm addicted to something, is it going to change how much I use? Yeah, I might use more if the price is lower, but I'm going to find a way to use heroin regardless, right? So I might be pretty unresponsive to price changes or fairly inelastic, right? So I could go ahead and kind of compute this, come up with my elasticity of demand. And I think if I remember right, let's see, I've got some tables here. No, scroll down. Yeah, where we are. Da, 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 da. We want the interesting stuff. So where's that? So here, I think this was like they found that, oh, see a cleaner table. And we're not going to talk about regressions in this class, but essentially they run some regressions to come up with like this price quantity. So taking the log is just a fancy way of getting these percentage changes. Sure enough, they found that demand for heroin, when the price was going up, people bought less, but it was inelastic, right? Less than one. Okay? And they did it a couple different ways. Now, another thing that was interesting that came out of this, and let's see if I can find this table. I think it's down quite a bit further. Where is it at? Da, da, da. Oh, no. Oh, here we go. So also notice they took like the percent change in the budget and see how does that impact how much they use of each one of these goods. So here it wasn't heroin, they had marijuana, beer, and cocaine. So when the budget changed, people bought more of each of those. So these are all normal goods, right? When people had more money, they bought more of each one of these goods. But they also looked, how does the price kind of heroin relate to how much people buy of these others? So when we have a positive cross price elasticity, so between marijuana and heroin, it's barely positive, but this would actually imply what? When the price of heroin went up, people actually bought more marijuana or used more marijuana as well. These would be substitute goods, right? Price of one goes up, I use less of that, more of the other. The weird thing that kind of came out of this is they also found that for beer and cocaine, that these were actually, sorry, that beer was also positive. There was these were substitute goods, but that for cocaine, we've got a negative cross price elasticity. So that means when the price of heroin goes up, people actually purchased less cocaine. So anytime we have these move in opposite directions or a negative cross price elasticity, we said this would represent that they're complements. So cocaine and heroin here, I don't know the story here. I don't, admittedly, I'm not, cool enough to, well, I shouldn't say cool enough, but I've never, I'm not a user of heroin cocaine, so I wouldn't know why these are complements. I would imagine the story is something like, you need cocaine to come back up after or using heroin or something like that just to function. But from the data, and it's statistically significant, which is something we won't talk about in this class, but they find that there's an actual complementary relationship for these heroin users between cocaine and heroin. But that beer and marijuana were actually substitute goods. Right? I don't know. So once again, this is like a weird example, but I think it's interesting because like we can think about there's markets all around us, right? And we can use all these things that we're talking about to really analyze any market that we're interested in. So here we're looking at the market for different drugs. We can use these cross price elasticities to determine whether or not goods are substitutes or complements. We can also use these elasticities to determine whether or not these drugs are inelastic or elastic. Okay. All right. So a bit of a digression from kind of our typical stuff, but I thought it was an interesting conversation based off what we were kind of covering today. We've got 5 minutes left. So let's go down here. We'll use the last couple minutes to quickly go through the quiz questions today. Shouldn't be anything crazy. So the very first question, right? We'll look here. If I've got cigarettes and the current price is $4, we're raising the price to 5. Okay. If I have a price elasticity demand of 0.4, this is telling me that demand is what? Inelastic. If demand is inelastic, right, I'm on the lower portion of my demand curve. When I raise the price, going from 4 to 5, what am I moving closer to? That unit elastic point. We said what is true at that unit elastic point? Total revenues are maximized. So if I'm on that lower inelastic portion, increasing the price will move me up the demand curve towards the unit elastic point where total revenues are maximized. So that increase in price should increase my total revenues. Okay. We kind of just went through this one, but if I have a cross price elasticity that's negative, that's telling me that when the price of the Y good goes up, the amount people buy of X actually goes down. This must mean I'm using these two goods at the same time or that they're complements. Right? Also, if it's a value that's above 1 in absolute value, that must mean my numerator is greater than my denominator. So remember, for this cross price elasticity, if this fraction is greater than 1, it must be the percent change in the quantity demanded is greater than the percentage change in the price of the other good. So there, that percent change in the price of good Y must be less than, right? I'm just saying this in a different order. The percentage change in the quantity demanded of good X. Okay. Any questions or want to see any more of this kind of worked out? And then there's no right or wrong answer here. As long as you kind of respond to question 3, you'll get kind of full credit. I just want to know, which module would you like to see most reviewed tomorrow? Module 1, 2, 3, or 4. I will take a look at this. The responses. So I think technically this participation quiz, these aren't due until the end of the day tomorrow. So a little bit different than the previous ones. I'll release the module 4 quiz. In fact, I'll do that right now. Module 3 and module 4's quiz will be due by the end of the day tomorrow. So a quicker turnaround, right? I try to create as much flexibility in this class as I can, but given that we have these exams, the last module we cover will always have, you'll always have less time for those quizzes, right? I have to be a little bit more on top of things. So we've got that module 4 quiz, module 3 quiz, and then the participation quizzes from this week. So yesterday's, today, and then tomorrow we'll have one as well. Spoiler alert, tomorrow's is going to be just like an opinion-based one. So it should be very easy as long as you get on and get it done. All those will be due by the end of the day tomorrow. And then on Thursday is when we'll take that exam. Okay. So make sure you're getting those completed by 11:59 tomorrow night. Then on Thursday, that time block between 11:15 and 3:15, you can take any hour and 15 minutes in that time block to start that exam and finish it. Right? Now, I've said this before, but that means if you want the full hour and 15 minutes, you need to start it. If it ends at 3:15, you'd have to start by 2 o'clock. Okay? I would probably just plan, especially for those of you who kind of show up to class every day, just taking it at our typical class time. It'll be 25 multiple choice questions, look very similar to that practice exam. It'll be scored for correctness, obviously, being worth a total of 100 points. And other than that, I will get up a little Word document as well that will kind of have like the midpoint formula and any other formula that you would need. It shouldn't be really anything other than the midpoint formula up to this point, but I'll kind of do that for subsequent exams as well if we have some additional formulas that you might need for those exams. Okay. All right. So I will stop the recording there.